stage Mr. George Raymond, Chief of Strategic Alliances at Pasquale. Please give him a well-deserved round of applause.
Morning, everyone. I'm supposed to have some slides, but anyways, I'm here to talk about quantum. It's a real pleasure. And I think you all know this great tool, smartphone, a cell phone. We all have one in our pocket, actually. And do you know that this machine is millions times more powerful than Apollo's computers, the one that sent the man to the moon? This is super impressive. And this is a pure result of the invention of computing, of CPUs, which themselves is a consequence of the invention of a transistor just after the Second World War. And transistors were invented by physicists, by quantum physicists who harness quantum effects to build this transistor. And actually, we owe quantum mechanics a lot. Not only it led to the invention of CPUs, it also led to the invention of lasers, atomic clocks, a key component for our GPS. Thanks to quantum mechanics, we also invented MRI. And I think that regarding the impact of these three main breakthroughs, it is fair to say that it was a quantum revolution. Nevertheless, we still have some computational challenges ahead of us. As an example, managing energy, managing the distribution of electricity is extremely complex because of the size of a data set, because of a number of parameters that need to be optimized at the same time. Understanding the interaction of biological molecules to speed up the discovery of new drugs is also out of reach of traditional solutions. So, what is the solution? Well, is to look at quantum a second time and to harness new effects of quantum mechanics, such as entanglement. I think you are familiar with the bit, that can take a binary value, which is either 0 or 1, and the quantum counterpart is called a quantum bit. And compared to classical, the quantum bit can be in 0 and 1 at the same time. And when you move to many qubits, when you start talking about entanglement, that Albert Einstein described as a spooky interaction at distance of particles. And with your n qubits, you can create 2 to the power n states, a bit like your classical qubit. But the main difference is that you can create them at the same time. You can create 2 to the power n states at the same time. And believe me, this number is staggering large. You are familiar with this exercise, to put a grain of rice on the square of a board chess. And you double the number of grain each new square. You start with 1, 2, 4, 8, 16. So you see the progression. And actually, at the very last square, you reach up to 2 to the power 64 grain of rice. Again, this number is staggering large. You cannot even produce it in a yearly production on Earth. It's a too large number. And quantum computing is harnessing this complexity. Imagine that you want to find the exit of a maze. With traditional computing, you will have to test all possible exits one by one, step by step, in a very linear process. With quantum computing, you will create an entangled state of all the possible paths and probe them all in the same operation, leading to dramatic speed-up of the computing. So, easier said than done, actually. These entangled states are very hard to see and to observe. It was firstly introduced by Albert Einstein in 1935. At the time, it was a thought experiment because it was out of reach of any experimental solutions. It took 3 decades to find a criteria to test the assumption. It took 2 more decades to implement it experimentally. And for this experiment, Alain Spey was awarded the Nobel Prize of Physics in 2022. 10 years later, physicists started harnessing this new effect and developed applications with that for quantum cryptography, or to find a new algorithm with exponential speedup compared to classical ones. It's only in 2001 that physicists learned how to control single atoms, leading to the creation of Pascal in 2019, with Alain Spey as a co-founder. In 2021, 2 of my co-founders were able to simulate quantum magnetism, quantum system, with up to 200 qubits, far beyond the capabilities of traditional computing, implementing the vision of Richard Feynman from 1982. And to close this panorama, I would like to finally quote my co-founder, Alain Spey. He said the following: "When there is no fundamental limitations, engineers find a path." And what I know from quantum mechanics is that there is no fundamental limit, and we will find a path. So what are the areas where a quantum computer is performing well, compared to traditional computing? Well, we have, first of all, cryptography. The Shor algorithm can actually break cryptography. Quantum computers are very good at optimization. Remember finding the exit of a maze? And you can see actually an optimization problem as finding the exit of a maze. Quantum computers are also very good at machine learning, simulating quantum system, as I told you.
They can also solve linear algebra, and finally are very good at database search.
Oops. So it's important to understand that quantum computers will not replace CPUs and GPUs, because they have specific capacities. And at the end of the day, all these 3 solutions will work together. It will be hybrid. And to this regard, you have to see quantum computing as the 3rd pillar of high-performance computing. And the cherry on the cake is that these machines are very low energy intensive. They are 1,000 times less energy hungry than CPUs and GPUs. And this is a huge advantage, because you can double down on the reduction of the carbon footprint. Thanks to the applications, remember, better managing the energy, but also by the usage of this machine. You have to know that there are different ways of building a quantum computers. Here, I put a few on the slide. It's not your business. You don't have to be afraid of that. Actually, it's better to see that as an opportunity. There are plenty of solutions to build quantum computers. There are large companies, smart people working on that, and they will find a way. What matters for you is to understand when and how to use the quantum computer. Where is the bottleneck in your existing workflow that you can solve thanks to a quantum computer? This is the important part for you. Don't care about the physics. All these vendors, and especially Pascal, we are all providing a software stack which is completely abstracting the complexity of programming. And you can program a quantum computer. It is as easy as programming any other computer. Quantum computers are also now a reality. We are not talking about science fiction anymore. And here you have the pictures of 2 of them. The first one is an IBM machine installed at the Rensselaer Institute, a US university. You can see this big cylinder, and this cylinder actually is a fridge, which is needed to cool down a chip at very low temperature. And when I say very low temperature, here we are talking about millikelvin. That's the price to pay to see quantum effects and to see entanglement. Remember, these effects are very hard to see. In our case, at Pascal, here a machine which is installed in a data center in Germany, we are controlling single atoms with light. So in our system, you will find a lot of lasers, a lot of optics, and also a vacuum chamber where we put our qubits. But fortunately, the system is working at room temperature. So it's easier if you want to deploy. So thanks to the hardware, thanks to the software, we are now able to implement real-world use cases in partnership with end users. Here you have a couple of examples in drug design, in electricity distribution, and generally speaking, any network-related challenge, it can be addressed with our technology. We have examples in finance, in maritime transportation, and also in smart mobility. So it's time now for me to conclude this introduction, and with three main takeaways. First one, this is, quantum properties that give quantum computers their inherent advantage versus classical computing, such as CPUs and GPUs. Second, quantum computers will not replace these solutions. Everything will work hybrid. The three of them are needed. And see quantum computing as a third pillar of your computing strategy. And last but not least, we will find the use cases together. We are providing the tools, both the software and the hardware, but you know the applications. You have the data. You are the domain experts. And after all, NVIDIA did not invent LLM nor AI. They just provided the tool. We are doing the same. This technology is developing amazingly fast. And my advice for you is to start your quantum journey now. The tools are here, and we are ready to help you. We have some partnership slots left for people who want to change their domain. I would like to thank UM6P for inviting me for this session. It was a great honor for me to be on stage and to talk about quantum computers. And a special thanks for Max Le Saff, who supported the idea of me giving a keynote and who helped me preparing the presentation. And thank you for your attention.
Ladies and gentlemen, another round of applause for Mr. George Raymond, Chief of Strategic Alliances at Pascal. And George has done a fantastic job of leading us into our concluding panel discussion, where we will listen to the minds and the great individuals who are shaping deep tech and AI on a global scale, with a specific focus on translating quantum theory into real-world disruption. Ladies and gentlemen, allow me to invite to the stage the moderator for this session, Dr. Satyam Priyadarshi, CEO, Reignite Future. A round of applause for our moderator. Yes, thank you very much, sir. The panelists include Karim Amour, founder and CEO, Opinion.ai, Andre Honig, CEO, Global Quantum Intelligence, Kate Hash, Deep Tech Advisor, OST Quantum Delta NL, Neil Abrug, Head of Quantum INRIA, and Anwar Benali, Team Lead, High Performance Qubit Farmer. Please welcome them.
So much. All right. Good afternoon. I think in interest of time, since I was already here on the stage, so I won't introduce myself. You saw, I'll ask my fellow panelists to start introducing themselves, and then we will have some question and answer session. I think our previous keynote speaker did a great job of giving the fundamentals of quantum computing. And now we'll go a little deeper into various aspects of it. So with that, may I ask Andre to introduce himself?
Thank you. Great to be here. A wonderful day and a half. Wish it was a little bit longer in Morocco and Ben Guerir at the UM6P. My name is Andre Koenig. I'm the CEO of Global Quantum Intelligence. We are a US-based economic intelligence firm in quantum technologies. We're celebrating 10 years in quantum in 3 years, and we work with governments around the world, investors in quantum technology vendors, as well as end users of quantum applications to make sense of this spooky craziness that is quantum. What do hardware roadmaps actually mean? What are the risks? What are the timelines? What are the opportunities? What are the geopolitical implications? Quantum is as much a commercial opportunity as it is a national security threat or opportunity, depending on your posture. And we hope to make sense of all of that.
Karim, can we go next?
Yes, hello, fellow. Happy to be here again. Great event, really great event, very profound, a lot of topics. I'm Karim Amor, a CEO of Epineon, a Moroccan innovation factory based in Casablanca, working with UM6P in a very deep level. We use quantum simulations for our biotech venture on simulating materials and also frequencies that we use. And we use also, we are developing also quantum post-quantum encryption. And I just wrote a book called Renaissance Now, whereas I advise people about the risk of hard AI and quantum computing, the good side of it, also the much dark side of it. So happy to be here.
Kate.
Thank you. I just want to echo Karim's sentiment. It's amazing to be here. I was here the first time a year ago. It was significantly smaller. I think my highlight for this year, the moderator asked it, was I got to know so many new people. I started on the plane already, had wonderful conversations at 2 a.m. about quantum mechanics. So really excited to be here. On my background, I'm a hybrid. So my name already tells you I'm half South African and half German. And I've spent my entire career in deep tech, supporting deep tech. And the interesting thing about it is that now, finally, and also thanks to UM6P, I don't have to choose between supporting deep tech in Africa or supporting deep tech in Europe. These two worlds are starting to converge. And that, I think, is really, really fascinating and something that we should grab and hold on to and use this momentum. So I started out at Unternehmertum, which is the German word for entrepreneurship. That's the entrepreneurship center of the Technical University of Munich. Then I went on to African politics. I was at the African Union advising them on entrepreneurship policy and entrepreneurship programs. And then I went corporate. For 5 years, I was at SAP, their accelerator program, SAP.io. And then for the last 4 years, I built a deep tech accelerator program called Intel Ignite for Europe. And very recently, I became free of any corporate bounds. And now I can choose who I want to work with. And so I chose to work in African deep tech and in quantum in Europe. And when I chose those two, I thought, okay, I'm going to be doing quantum because quantum really doesn't exist yet in Africa. So I'll be doing quantum in Europe, solely in Europe, and I'll be doing African deep tech. And I never imagined I would be sitting on a quantum panel in Africa. So UM6P, thank you for that.
Neil, can introduce.
So thank you very much. Very happy to be here. This is my second time at UM6P, so very happy to see the enthusiasm about quantum. Having a specific panel, like have been said, on quantum here is very encouraging, and this is something quite exciting for me. So, Neil Abrug, I am the director of the quantum program at INRIA. INRIA is a research organization in France. It's a sort of national lab focusing on computer science. When we focus on quantum, typically, our researchers work on the next generation of quantum computers. So we have, for the last years, several machines, intermediate scale with noise and so on. And our focus, what our researchers do, is error correction, which is what we need to have fault-tolerant large-scale machines used by companies like Qubit Pharmaceuticals. And yeah, and before that, so I have been leading this program for a year, but for the last 6 years, I have been with the French government. I prepared the national French quantum strategy since 2018, convincing policymakers why quantum matter, what are the opportunities, what are the threats, and why we should invest in such technology, even if it is very uncertain, even if There was scientific still uncertainties in 2018. There are still scientific uncertainties today, but convincing them why we need to invest in quantum, why public sector needs to invest in quantum. And I have been leading this strategy since 2021 up to last year. We built a lot of international cooperations with European countries, with North American countries, and began discussing with also Middle East, African countries. So very excited to be here.
Thank you. Anwar?
So my name is Anwar bin Ali, and I'm actually a computational scientist, and I am the head of quantum chemistry, high performance and high accuracy quantum chemistry and material science research group at Qubit Pharmaceuticals. Before joining Qubit Pharmaceutical, for the past 15 years, I was one of the lead scientists at Argonne National Laboratory, which is a US Department of Energy lab, and I was heading their technology in bringing high performance chemistry and material science to high performance computing. Since I joined Qubit Pharmaceutical, my job is very interesting because basically we try to solve these very complex problems that are in quantum chemistry from a classical approach where we view computing as a tool. The main problem that we try to solve is the chemistry that comes from creating new drugs, and we see and view computers, either CPU, GPU, or QPU, as a mean to solve a problem. And this is what I find fascinating, because we can bridge the real applications to whatever the technology allows us to get access to, either be it a quantum computer or a GPU or a QPU or CPU.
Thank you. So, Andre, since you said that you provide intelligence to governments, investors, and others, so can we say, what does one really understand about quantum computing, and how should we really think about it?
And you helped me do that, which I'm very grateful for. I'll give a little bit of a different answer, and I let my more smarter and the more technical colleagues give the real answer. What I think I want to tell you about quantum is that it is different. It's an opportunity, and I don't think that very many people understand it. There's the technology, there are the products, we'll hear all about that, and you know, be it Pascal or the representatives up here are fantastic in it. But sometimes life changes, right? Humanity changes, and that course of change always was brought by a technology. Fire is a technology, right? The wheel, electricity, the internet. And then you have incremental changes in between that. For me, artificial intelligence is an incremental change. It is classical technology rooted in our classical understanding of reality as we see it here at the beautiful campus of UM6P. But it's not a change. It is not different. I had my first AI startup in 2011. I know what it can do, and it's going to have a huge impact on our industries, our countries, and amazing to see what you are doing here in AI. But allow me to be brutally honest. You're not going to catch up with Elon Musk or Sam Altman on AI. You don't stand a chance. So what you have to do is something new, something different. And that is what quantum is. Quantum being rooted in this spooky quantum science, quantum entanglement, quantum superposition, which just celebrated 100 years, that the ecosystem is now building technology on, which today is at a point where it can be incremental. It can be incrementally better, faster, cheaper, more environmentally friendly, less power hungry. And that will continue as we develop those technologies. But there will be an inflection point in quantum as well, if we're lucky, if we're making it work, and we see this real quantumness, when all of a sudden we can do something that before we couldn't even imagine. And that is the opportunity. That is what quantum is. And the big misconception is that you will be able to buy your way into it. It is not like AI. It is not like blockchain. One of the questions that I hate most in quantum is, when is the iPhone moment in quantum? Don't ask about the iPhone moment in quantum. Ask about the first nuclear reactor in quantum. This is a large system type of technology. I really hope we'll never see an iPhone moment. This is a national strategy. This is a large-scale Google collaborating with IBM, with Microsoft to make it happen for the change of humanity kind of opportunity. The nice thing is, it is early, and it is still very cheap. Everybody can do it. You can do it. Anybody in Morocco, in Africa, if you were to collide around it, can be successful with it, if you're willing to make that bet and take that risk. That is how I view quantum. I'll leave the more technical and product descriptions up to you guys. But it is a big opportunity that will change our lives if we indeed make it happen. I think we will, and that risk is something that you need to look at.
Karim, you want to add a comment on that?
Totally agree, except that I say that AI is still a technology that is a disruptive one, particularly generative AI. Us, on the way we use AI and quantum simulations on a daily basis, just believe in generative AI just for communication, because it's a language model. But as long as you get into deep tech, you need real strong data to rely on. I think both of them can help. As far as quantum computing is concerned, we were into quantum computing 3 years ago because we wanted to discover things that you couldn't discover with AI. I mean, explicable AI, because we didn't have enough data to be able to produce the result that we were looking for. And what we were looking for was materials that allowed us to go deep into the skin in a non-invasive way, and also frequencies to do that. And on the way to do it, I think quantum computing is the real leapfrog, because it helps us see the future in dimensions of time that could never be, have never been achieved till today. Let's take the sycamore example, for example. About 3 years ago, they said that they were achieving what they call quantum supremacy. And they said, well, out of, I think it was 200 seconds calculations, they achieved 10,000 years of what a cloud computer could, a supercomputer could achieve. So in the human mind, 10,000 years is not really something you can apprehend, because it's 10,000 years. So I agree with my neighbor saying that it's another technology. The CEO of Pascal was saying it. It's another way to approach life. It's more than you are going to another dimension. And you discover things that sometimes can scare you. I mean, we use it in different ways. We use it in a logical way and in a digital way. In a logical way, you use it where you use a real quantum computing using few seconds of calculations with no noise that can bring you something that you have to align with GPUs and in a digital way to be able to verify the calculations. You're in a sandbox. You're not really in a calculations per se. But I think this technology, the best thing I can advise to our countries is to train people on working with this technology, programming this technology, although Pascal company can help up with that. We have only a few thousand people working on it, programming it and knowing what it's about. You have 8 billion people worldwide. You can imagine the leapfrog you can make with such a technology in our countries.
Thank you. Thank you. So connecting to the discussion here, like, can we reduce the time for certain things? And since we're talking about humanity as well, so drugs and pharmacy and medicine and materials are very important. So how does quantum computing or quantum technologies help in our journey for the future pharma or materials?
So if I may, so I think it's very important to understand that there are hype phenomena and real things that are happening. And it's very important to really address the things correctly, in the sense that a quantum computer or a computer or all these things are tools. And tools are deployed to solve problems. And the first step to do things properly is to be able to isolate which tool is used or is needed for the problem that you have to solve. Using the maxi hammer, the giant one, to solve the tiny, tiny problem that you have is kind of a useless problem. And I think that the biggest issue here is to be able to set the scales and know what quantum computing will be used for. Not every problem that we have will be solved by a quantum computer because, as George said earlier, we are trying to solve, quantum computers have this scaling that allows us to have combinatorial type of problems, or whenever we have something that is 2 to the exponential of something in the complexity, this is where a quantum computer can solve it in a linear scale. What this means is that we need to be able to isolate and insulate where the problems becomes this complex. In reality, these type of problems are not that common, but unfortunately, or at least fortunately for quantum computers, when we come to be able to solve new medicine, target drug designs, and a very simple and very unfortunately stupid example is aging or oxidations. We all know, we all heard, use oxidants. Take this food, it's antioxidants for you, it's good for you. What does this mean? This means that it just blocks a very stupid reaction. It's just iron and H2O2 that combine together and release this oxidant that destroys our health. This equation is so complex to solve that we have to use very, very large supercomputers now to be able to control them. If we wanted, for example, to isolate this iron that is creating all these problems, it would take a huge amount of computer time. But these are this type of problems that a quantum computer can solve on a blink of an eye, or at least very quickly. There are material science problems, for example, to be able to design batteries. We can do that now with the classical computer. We can do it very well. We can approximate all this comes to solving an equation that is called the Schrödinger equation. This equation is very, very complex to solve, so we can take very good approximations with classical computers. We can even break a lot of barriers to be able to solve it to an insane accuracy. But the cost that we have to put is insane. We need supercomputers of government sizes to be able to do it. We have to run for significant amount of time, and then the amount of energy that we use to be able to solve it is crazy. For example, in our case, we use the supercomputer at Argonne National Laboratory. It's 35 megawatts per year of electricity that is used to run this computer. And all this to be able to do this type of band gaps or this type of scientific calculations that we need to do to be able to design new drugs or to find a new generation of batteries. So yes, it's important to realize that there are a lot of problems that exist now that we can solve. But also, as everybody said, if we don't form the next generation to be able to use a quantum computer, the moment a quantum computer will reach the point where it's usable, you will be still scrambling, trying to defy your problem and trying to build the tools to solve it. So the real issue here is to be able to identify your problem, start deploying the tools to be able to solve them with classical computer, mark where is the limit that you cannot achieve, either be it size of the system, energy-wise, compromise, and then see how the quantum computer is going to be helping you in solving that problem.
Yeah, so if we are going to use quantum computers, that means to solve complex problems, that means we need people to do that, right? The tools themselves don't do
exactly.
anything.
You can
so
buy
Kate,
the tool, but you cannot have the people.
Right. So Kate, how does we develop the ecosystem for developing talent?
It's hard. I mean, I was just watching Georges and his speech, and I thought, his role is infinitely harder than any other founders, because he's not only pitching his startup, he's not trying to sell and to get investors, he's also educating us on what quantum mechanics is, right? And he's doing science in the background, right? He's a scientist, and most quantum founders are all of them are scientists. All of them are scientists, and so I think that that's something that we need to address all the time, is that quantum founders are working in the arena of science, but at the same time they're entrepreneurs. Now, how do you bridge that gap? I'll tell a story about a startup that went through our accelerator at Intel Ignite. They were in our very first batch. They have developed a cooling system for quantum computers. So what George was mentioning, you need very, very low temperatures for qubits to remain in a quantum state. They've developed an alternative technology to the state-of-the-art, which is based on magnetic cooling, not on helium-3 isotopes, which you can find in abundance on the moon, but here on Earth you need to decay tritium, which is a byproduct of a nuclear reactor. So, great, right? They're developing a magnetic cooling system which will be heavily needed when there are a significant mass of quantum computers, which there aren't. So how is this company going to survive, right? They've also got to do that whole R&D phase. They've got to do their decade of science to be able to get to their solution. And then they need the market to catch up, and then they can sell. And that's what we had to teach them and hope that they would be able to learn that, because you're not going to get an MBA student from HEC to follow that route for the next 15 years, right? They're going to have to do it. So what they've done, for example, is they've developed an intermediate technology. So it's kind of what you were saying, Anwar, you know? They've developed a rapid testing solution for other electronic components that also need very low temperatures, but not quite as close to absolute zero as quantum computing, so they can develop their technology along the way. And that is also their investment story. It is not cooling for quantum computing yet, because they were able to raise a round based on that story in pre-seed phase and sort of a pre-seed extension. But now they're doing Series A, Series B, and that's when an investor looks at them and says, okay, you need to be selling at that stage, right? If you've got an investment, a business case that is based on quantum computing being mainstream, I'm going to sit back and wait as an investor. I'm going to wait to see that happen, and then I'll invest in you. But the company can't do that because they need to R&D until then. So I think that that is the crucial part, is that quantum founders are scientists and need to do science, but they need to be entrepreneurs at the same time, and we need to teach them how to get there. And I think that sort of brings us back to why we're sitting here today, right? The interesting part in the quantum debate is that when you ask anyone in quantum, and I've asked everyone here on this panel about their perspective on timelines, you get 5 different answers, right? Ranging from in the next 5 years to I'm going to be a geriatric by then. And so what I do think is very, very relevant is that you start now with developing those future quantum entrepreneurs. You put in the decade, 2 decades of research so that you can, when it comes about, whether it's in the next 5 years or in 25, so that you have that body of people who are skilled to be able to handle the onset of quantum. And I think that the time is now for UM6P to start quantum computing. Just a little hint here. But I think that this is probably why this is happening today, is because UM6P is looking at it as a future technology that they need to invest in. And what do they invest in? People, right? So that's what we need. We need more people in the area being skilled to be amazing scientists and entrepreneurs.
Thank you, Kate. Neil, since you worked in France in multiple agencies, and I think over the period of time you must have interacted with a lot of talent in different areas, especially now that is one of the areas is your error correction, right, research. Now, how do you take that kind of knowledge and bring it to Africa? And the experience and the knowledge that you have gained in France, how do you bring that to Africa?
Yeah. So, what is exciting about this field, and we shared with the different policymakers, is that even if we have these uncertainties, scientific uncertainties, like have been said, we needed entrepreneurs. We needed also private investment. And this was a movement that became around 2015 when big techs invested heavily in basic science. Normally, quantum, between 2015 to 2025, shouldn't be a private sector topic. It should be a university, national lab topic. But we had this movement, and we needed to accompany the movement of people willing to build startups. And money was quite cheap at that time, which is no longer the case today. So today we still we see that the first machines are quite there, but we need to invest on the applications. We need to discover new algorithms. We need to build with the scale we have with these hardwares what we can do at the industrial level. I'm quite optimistic, like André, that in the next 5 years we will see some very specific sector applications on these hardwares. However, a lot of people says we have a shortage of money, we have a shortage of talents. Billions and billions of money have been spent on quantum, both from public side and private side. No, we don't have shortage, neither of talents nor of money. We have a lot of talents and money, but the efforts are very are not consolidated. That's the real problem. You have 10 competitors doing the same thing with just 5 people, with not the right amount of investment, and everyone is thinking he's the best in the world. If you put them all together, working together, building large-scale, fault-tolerant quantum computers, you need probably different type of qubits. We need people working on error correction. We need people working on how to connect these qubits. So people that came from quantum communications, people working from the classical HPC form. We need large-scale programs with all people around working on the same goal, at the government level, but also at the private level. It's unviable having 200 startups worldwide working on quantum. That's my real conviction.
So, Andre, Neil just talked about how to collaborate, and investment has been in billions of dollars. Now, how do you see the investment landscape today, and what needs to be done to maybe address some of the challenges that Neil is talking about?
Well, I'd like to underscore first the point that Neil made. I think there are too many tourists, let me be honest, in and around quantum. You have to commit to it. You have to be willing to take that risk. I had an argument with my girlfriend on meditation the other day, which I've done 2 or 3 times. It's not something that my brain computes. And she said, you have to live that lifestyle. You have to commit to it, right? And it's the same. We've committed our careers and lives to this. It is not something that you're going to catch on. So money isn't the issue. There's a lot of short-term issues where startups fail to find lead investors. They are 6 months late on closing their round. And I think these founders are getting very good at it. But what's really missing is also strategic investors that have the risk appetite and the ecosystem understanding beyond going to a couple conferences and saying, oh, I invest into quantum, to build a real platform that's not just private for commercial aspects, but public-private or national level scale or transnational level scale, and put those dollars in, and it is pretty cheap. We had a conversation, right? What did you say, 3 billion or so, maybe, to...
I estimate that 2 to 3 billions would allow aligning all these companies toward one unique goal.
Just think about how cheap that is. For that, you don't do anything in AI, nothing.
In AI, we are investing hundreds of billions, just for comparison.
I think it's important to bring back the reality of the things at a scale where countries like Morocco or African countries can realize the things. I agree with you that $2 to $3 billion on the scale of the planet is not a lot of money. However, when it comes to a scale of a continent or a country, $2 to $3 billion are starting to hit the percentage of the GDP of that country. So when you ask citizens to invest in a technology, that technology needs to bring back some value to the technology. I'm not saying that quantum will not bring that, but I'm just saying that there are scales. Additionally to that, however, where I align with you is that this is the time where investments from governments in, for example, in universities and being able to train the next generation of computer scientists who know how to handle a quantum computer will not happen, unfortunately, at the level of a company itself, because at this point we're still at a research level. However, we need to realize that you cannot form, even now I feel like forming an engineer on HPC is kind of something that is gone. And this is not just at the level of Morocco or Africa. I've been in academia for all my career for the past 20 years, either in France or in the United States, and it's more and more complicated to find students who know how to program a differential equation on a computer without just calling a library or something that is already done. We ask students, how do you know how to program? They're gonna say, I'm very good at Python. Python is not a programming language. You need to understand that Python is going to allow you to call JAX or any PyTorch library to do your AI, but this is not how you optimize software. If you want to achieve really this type of clever levels where you can use a supercomputer correctly, you need to be able to have the computer science skills. You need to be able to understand physics and chemistry and translate your problem from chemistry or from fluid dynamics into a differential equation, into a software that you optimize on a supercomputer. For AI, for quantum computers, now you're complexifying the problem even worse, because not only that, you need to start understanding the rules of quantum mechanics, and even if companies like Pascal or even Qubit can generate software that can make this easier, you still need to make that effort. If you wait until the quantum computer is fault tolerant, is ready, it's available, and you can buy it from the store to be able to start forming your next generation of students to be able to program it, you 10 years later, wait for the next technology for the revolution, maybe you'll catch up. So this is where I align with you, André.
And I agree with everything you say. By the way, Qubit Pharmaceuticals, one of the smartest teams and best products, love them.
Thank you.
Except that one thing. Value, you have to show value. I think that's the fundamental flaw that I see with every government, every investor, every user that I talk to, and I do that with a big team every day all over the world. It's not about the value of a specific use case. As soon as you're looking for ROI on using your quantum, you will fail. This is, I'm a finance guy by training. This is like a stock option. This is an option on your future, securing your own future of your industries and your national security. It is not about short-term value.
And I would add to that we have to be very objective. Today, we are living a bipolar world. If you look at it from the eyes of AI, you see what's happening. We all lived the Sputnik moment of DeepSeek and how people reacted. Quantum computing is even 10 times, even not 100 times stronger technology as far as the government is concerned, as far as research for achieving fusion reactors, medicine, cryptography. We work in post-quantum cryptography. And by the way, yesterday we were NIST compliant with one of our quantum technology on post-quantum, and I'm very proud to announce it. It's a Moroccan company that did it. And I think cryptography in quantum, post-quantum cryptography is one of the main issues we have to face. It's a short-term one. We saw what happened lately in the south of Europe as far as electricity is concerned. You have a lot of hacking all around. We saw the film in Netflix dealing with this cutting of electricity everywhere in the US. My book, Renaissance Now, I relied on the hacking the public and private key through a quantum computer, and I explain how it happens. I think this post-quantum cryptography thing is of a government responsibility to handle it. It's a sovereign technology as far as research is concerned, and I don't believe, objectively, that any governments will come together to try to find a solution for everybody. In the book, the last scene of the book take place at UM6P, bringing all the governments together. It's a dream. The dream is going even further today after some elections that you're aware of. And we have to be very objective. Every single continent has to work on the technology or give hands to other people to make it together. We can work on 2, 3, but not everyone, because it's an impossible dream that we're facing as of today. And if the quantum technology has to come to a stable situation, you know, there is one magic that happens with quantum. The unique place where quantum is perfect is nature. It's when you see the plants. So it's something that God provides and that we can mimic. We use biomimicry in our company to find also some things that we work on. But quantum is really a sovereign thing that we have to handle. We can partner 2, 3, 4 countries, but the whole world, very difficult.
So lots of discussion, a lot of technology aspect, complexity, but then at the end of the day, it's all nature. If we understand nature, we will be good, right? But at the same time, there are a lot of young people here, and if they want to start their journey in quantum, can we get an answer in one statement? Where do they start? Going through the all panel, one statement. Where do they start?
I'm going to be biased, so I'm going to say, starting by a class of quantum mechanics, the easiest access would be do something where you have to solve the Schrodinger equation either for biology, chemistry, or material science.
Neil, your comment.
So in the same spirit, starting to try to play with these machines. And if there is something exciting about quantum computing is that every time someone claims a quantum supremacy, someone else a few months ago claimed a classical way to do the same thing. That means that even if one day it doesn't work, we would enhance classical algorithm, which is a good thing, because right now people was just enhancing step-by-step classical algorithms. So we should look at the fundamental concepts, what calculation is. It's about mathematics at the end.
Kate, one sentence. Where do they start?
I hope they're going to start here. I think that, you know, there are a couple of ecosystems around the world that are leading in quantum. The US is obvious, Canada. In Europe, it's France, it's the Netherlands, it's Germany, Munich. China, yeah. It's the Nordics. Hopefully here there's a high-performance computing center in Cape Town, but I haven't found anyone there on their team yet. Yeah.
Karim?
Well, I would say I will tell you a story. I met, we had a meeting with Hisham Al-Hati, the president of UM6P, 2 years ago. Me and some of my scientists in the team and associates. We were in his office and we told him, listen, we think we can build a quantum computer per se. He said, what? I said, we think, as Moroccan scientists worldwide, we can build the quantum computing. He said, but you know what? We have a class of quantum computing inside the university, which I didn't know. And I think UM6P is paving the way to what is the most important thing to answer your question, human resources training. It is the heart of what you want to do. Then you'll take it from whatever matter you want to put them in. You want to put them in the refrigerator thing, you want to put in classical calculations. And I believe very strongly in hybrid computing, which is using AI to achieve quantum results, and using quantum to achieve AI results. It goes both ways, and I think they're very intertwined. And if you see the technologies that are involving Willow's chip of Google showed us that they could correct the errors on the way. Microsoft, with their Marjana technology, showed us that we can intertwine ways of handling things so that we don't have any more noise. A lot of people are working on it, but I think as Africans and the Arab world also, we have to be proud of being able to partner or have our scientists go and disrupt the status quo that we're looking at today.
Thank you. Andre, your last comment.
What I said about meditation earlier, you cannot be an observer or a casual hobbyist. That can only be a lifestyle. The only way to start in quantum is to be an active participant of it. Get a stone, chisel into it. I'm going to be the smartest person in quantum in all of Morocco, and go network. Before you pick any ecosystem, any partner, everybody here is on LinkedIn. Everybody in quantum tends to be extremely responsive. It's a small community. We love talking about it. We love helping. We also need talent. And before you make any decisions, before you ever say a word about quantum, spend 6 months at a minimum in silence, networking, learning, reading, asking questions, and then you'll see the opportunities. But it's not a hobby. You cannot observe it. You can't observe quantum, right? You can't observe.
Perfect. So in interest of time, we'll probably take 1 or 2 questions from the audience. So if we can have the lights on in the auditorium, and then if somebody can, if they have questions, please ask, tell your name, what you do, and we can ask the question to the panelists. We have the lights in the auditorium, please.
Hi everyone, my name is Salim Suleiman, and I'm very happy to join this amazing communication. I am a consultant blockchain and enthusiast about the technology. And my question is about the quantum computing. Actually, how can I try to practice on this area, like try to train ourselves about this technology? Is there any tools that we can begin to see the technology, or how can we try to practice? That is the question.
Omar, you want to take that?
So the chance today is that we have, through access to the cloud, different hardware platforms. You have platforms from IBM, from Pascal, from Condila, from IQM. All the hardware providers don't deliver their machines only on-premise. They do, but they also give access through the cloud. All the platforms are accessible through Python, even if Python is a high-level.
You know what I mean.
Yes. But for a first step for students, they for sure need to understand how the libraries have been set and so on. Mainly the most difficult thing is that every one of them have a different frameworks for programming these machines. Something that is missing is a real software ecosystem when we can change from one application, having the same application, building the same code, and changing just some headers like we do in classical computers. Changing from ARM to x86 is not easy, but it's easier than changing from one hardware to another.
I think in interest of time, I've been asked that we need to wrap up this panel. Please give a warm thanks to all the panelists. As Andre said, please connect with the community. It's a small community. People are ready to help. Those who are interested, please connect us on LinkedIn to all the fellow panelists, and you will get help as needed. Thank you so much.
Thank you to our amazing panelists and experts for sharing their insights and expertise about the incredible world of quantum computing. Now, as we come close to the end of this incredible summit, it is now time for us to reflect on the journey that we've had together. And to navigate us through that journey, we are honored to have none other than a visionary who actually conceived and brought this summit to life, Mr. Yassir Larziwi, to deliver his final words. Please give him a warm and big and well-deserved round of applause.
Hi again. As we come to the end of the Deep Tech Summit, which is the hard part for me, I want to say that I didn't prepare any closing remarks because we are in a family, and it's gonna just be reflecting about the insights that we all had the chance to gather during the 2 days, and also to thank the people behind the success of such an event. I mean, during these 2 days, we had a chance to discuss a very important topic, which is redefining progress. Redefining progress is a very strong word. It's a very strong expression. Redefining progress means redefining civilization. And I want to ask you a question. Do you know where the origin of the Homo sapiens civilization happened? In what place we have the first Homo sapiens, our ancestor? Do you have an idea? Anyone? I mean, it's less than half an hour from this place. The first Homo sapien, the ancestor of human civilization, happened in the mountain of Idul, 3,000 years ago. And this discovery happened 2 years ago, and it was published in Nature. This is not a coincidence, where we, after thousands of years, after 300,000 years, we're discussing in the same place our ancestor started the journey of the human civilization. We are talking about redefining progress. Redefining progress in an era of AI. AI and deep tech is more than just a technological leapfrog. It's something bigger than any technical evolution. It's not mechanization. It's not finding a fire. It's something that is hacking the very own capabilities of the human being. I don't know if I already talked about it, but interacting, reasoning, this is something that's always belonged to the human being. And in this last panel, we were talking about quantum. And the intersection of quantum and AI is just mind-blowing. I mean, all the problems, all the reasoning, all the algorithms that defined civilization could be challenged. This is huge. And for Africa, it may be something that will allow us to accelerate the technological developments, but for the human species, this is something big. I'm not exaggerating. Many philosophers, many experts are scared for the next generations. They don't know to what extent AI can change the human civilization. But the good news is the future, the progress, would not be defined or redefined by AI. It would be redefined by change makers like yourself, by people who are going to be discussing their values, that are going to be defining their ambitions, that are be discussing what kind of civilization we want to live. So this is a very high-level discussion that is taking place at the exact place where the human civilization started. This is super important, and it's no coincidence. So during these 2 days, we were also a little bit talking about some very practical use cases of AI and deep tech. We talked about very urgent matters. We talked about agri-tech and how we can apply to improve the food security and ensure the food security, not only for Africa, but for the whole world. We talked about health tech. How can we use AI to save lives, to increase the span, to increase the life cycle of the human beings? We talked also about clean tech, green tech. Clean tech and green tech is about saving the planet. These are urgent, big issues that will be hacked, that will be transformed if we can merge AI, quantum, and deep tech. So these are very important subjects that were discussed in this place, in UM6P Bangui in Africa. But I want to also underline that I am and we are super humble. We are not saying that UM6P Bangui or Africa is at the forefront of advanced technologies. We know and we are humble to say we are just in the starting points. You know how many billions of dollars are invested every week in Silicon Valley? Every week, $2 billion are invested in venture capital in startups. In Africa last year, the whole year, it was about 2 billion. The gap is huge, and we are aware of this gap. We are not crazy to believe that we are on the forefront, but we are crazy enough to try. All we are trying to do here is to try, because we don't have a choice. Africa has its place. Africa has its chance, but the only way to do it is to try very hard, is to sacrifice, is to come back for the diaspora to contribute, is for the local researchers, students, to believe, to want to make a difference. If we succeed, it's okay. If you don't succeed, we would have tried. But believe me, we need to believe in ourselves. We need to believe in ourselves to the point of illusion. We need to believe in ourselves in the point that we would be sure that someday Africa is going to be one of the nations, one of the continents that is defining the future of our world. And redefining progress is benefiting to the many, not just a few, as I said yesterday. It's benefiting to all continents, not just one or two. And only Africans can try, can do it themselves. Nobody's going to be helping. People believing in Africa will be here to support us, but we need to do it. And I always say Africa doesn't need savers. We know how it works. We know that quantum needs chips. We know that deep tech needs billions of dollars. We need infrastructure. We have playbooks all over the place. You can even ask ChatGPT, please, what is the roadmap to develop a deep tech ecosystem? And it's going to be very good in developing this roadmap for us. It's not about someone who's going to be saving us. We are looking for doers, people who are going to execute. And execute not in a perfect environment. We know how difficult it is to develop deep tech solutions in Africa. We are aware of that. Anything you do is difficult in Africa. But we need to be aware that this is the only way to push things forward. So we need doers who accept the constraints and the realities of the African continent. And you all do. You came here all over the world, from all over the world, to UM6P Ben Gurion, knowing that this is not a perfect continent. Legal framework is not perfect. The market is fragmented. Infrastructure is lacking. Youths are looking for good education programs and they don't find it. But you came all over the world, from all over the world to Africa, because you wanted to contribute in making this dream, this big dream, a reality. So yeah, maybe we are crazy, but we are just crazy enough to try as hard as we can and to sacrifice this generation's time and efforts, not maybe for us, because the results maybe not be super clear for this generation, but at least for the next generation, for our children and grandchildren. They're going to be thankful for the efforts we made. This is important. This is like being a militant for a better future for this continent. So this is the vision. This is why we're here. We're not praising that we are the best. We're not praising that we are developing high-level kind of technologies. This is not correct. We're still raising less than 1% of the total VC in the world. This is a reality. We're here because we want to try. We are here because we don't accept this reality. We are here for the only reason that we are a generation that wants to change things. And the only way to do it, guys, is to work hard, is to believe in ourselves, is to sacrifice, and to invest in doing research, inspiring others, and believing in ourselves. This is super important. And this is the exact things that we've been doing through the 2 days. Nobody said, I'm going to be changing the world today. Everyone was saying, I want to try to change the world from Africa to the world. So this event wouldn't have been possible, and this vision wouldn't have been possible to implement if many people, hundreds of people contributed to its success. It's very hard to succeed in building a collaboration platform where I think more than 5,500 people came actually to Ben Gurion to discuss this. And it was super qualitative. 200 speakers, 5,000 attendees, 66 sessions, 45 venture capital firms, 900 entrepreneurs. They came here, they worked, and all they were looking for is not to attend the tech show. They were here to make action. They were here to network, and they were here to build the future. So for those that made that possible, thank you very much. I want to start by someone who's not here. And it's much easier for him to thank him because he's not here. And it's the presence of UM6P. Mr. Hisham Habti is a very special manager. I met him, I think, more than 15 years ago in another project, in another environment. And he was the guy that was empowering. He was courageous enough to empower not only his team, but his peers. He had the leadership, and he had the courage to empower everyone that has an idea. He never said no when there was hope, and he always had the courage to say no when it wasn't no. We need this kind of courage. We need people who are able to believe in the potential of their teams, in the potential of their peers, in the potential of the dreamers, the change makers that are willing to change the world. So his leadership made the university very special. Everyone you see here was made by teams that believes in leadership. So I want to thank him. Please give him a, big round of applause, even if it's not here. But that would make sense. I want to also thank a very special group, a group that's made this DTS possible. I think the idea was born 3 years ago. And the first thing I did, I started reaching out to my network. I started reaching out to the people I know in Silicon Valley, in Europe, talking about deep tech in Africa. And I'll be frank with you, I mean, very few could buy in this project. Very few believed that deep tech can be born in Africa. Many told me, look, the best thing to do is to look for shallow tech, for apps, and try to digitalize the existing services so you can improve the lives of Africans. And this is good enough because maybe an international company could acquire this company, and it will create some jobs, and it will make a difference. And I didn't give up because there is a simple reason. When I went to Silicon Valley for a visit and for a very short immersion, 2 years, I went there for one reason. I wasn't there because I wanted to build a company or to raise a fund. The only reason was I wanted to discover what makes and what made this Silicon Valley what it is today. The question I had, why Silicon Valley had the ability to create more than 700 unicorns? Why the most advanced technologies were born in a very small area, less than 100 square kilometers? I thought that it was about people genius, coding, creating new technologies, and these people don't exist in any other place in the world. But I met Moroccans. I met a neighbor who studied with me when I was in high school there, creating one of the biggest companies in the US in Silicon Valley. I met people coming from all over the world, from Nigeria, from Kenya, from Egypt, from Asia, building the most advanced companies in the world. And I started asking the question, what's going on here, guys? What allows you to build such an amazing ecosystem? Is it the human capital? Yes, it's the human capital. Is it the system? Yes, it's the system. Is it the fact that you have the infrastructure? Maybe not. I mean, this kind of infrastructure doesn't exist. I mean, it's one of the best in the world. The recipe or the thing that was exists in the Silicon Valley and doesn't exist anywhere else is the self-belief. Everyone believes in changing the world. The motto is Silicon Valley is change yourself, change the world, and it's happening here. Everyone believes in the capacity to change the world. So the self-belief, again, to the point of illusion, allows the human being to extend his capabilities to things that are even not imaginable. Elon Musk, who is not a rocket scientist, decided to go to Mars. Can you imagine he defied NASA? I mean, NASA has been there for hundreds of years, and it's the only agency in the world that could build rockets. Elon Musk came, who is a technical guy, smart enough, but he decided to build rockets to go to Mars. It works. This is the exact spirit that makes things happen. The human being, our species, is one of the smartest species on planet Earth. When we believe, we achieve. And the spirit, we need to adapt it here. If Africans believe in their capacity to build new technologies and new ventures that would be able to be scaled all over the world, we will achieve that. Another team I want to thank is people that believed in this crazy dream. So we wanted to launch the DTS. We needed top-notch people. We needed executive investors. We needed people who already succeeded in Morocco, in Africa, and all over the world. So we started forming what we call the strategic committee. And these are not top-notch people. They don't have time. They're running companies. They're running incubators. They're running multinationals. They're executive in the best institutions in the world. And we started asking one by one, guys, can you help us? We don't have the means to go and ask one of the biggest consulting groups because it's going to be costing a lot of money and because we don't believe in their capacity to help us. We need you to help us. So we pitched the projects like if it was a startup, the Deep Tech Summit, a platform for collaboration, a platform for networking, a platform for action, not only for Moroccans or Africans, but for deep techers from all over the world. And we started pitching the first one, the second one, the third one. And what's weird in me and my team, who were like entrepreneurs pitching a crazy startup, we started getting a yes from people who don't have time. And when we asked them, why do we believe in us? They said, because you're passionate. You believe in what you're doing. And we want to help you guys for free. They were volunteers. And I don't want to cite all the names, but without these guys, I don't think we would have been able to succeed. So guys, thank you very much, and I would like you to thank them. Big applause for the strategic committee of the DTS. And finally, I want to thank another group of people. What do you want to say? Okay. Yeah, I mean, yeah, maybe, yeah. But you know who is Nisreen, who is now hustling me. Nisreen is a member of the DTS team. And Nisreen and the other members of the DTS team are a group of people who made this possible. You know, there is no dedicated team to DTS. These guys are running the DTS and also running all the other incubating program in UM6P, more than 18. And also they're running our presence in GITEX, they're running the investments efforts, and they're not dedicated to DTS. You would have thought that there is a group of people that are building the DTS. That's not correct. These guys are building the ecosystem and they have also been involved in organizing the DTS. I want to say just a few words. I'm very proud to be a member of this team. I'm very proud of you guys because you are one of the main reasons why I still think it's possible. You've been working day and night. You've been working during the weekend for more than a year to make this happen. You believe in our potential, and please accept my heartfelt thanks, and please give us the strongest round of applause. Thank you, team. Radi, the CEO of UM6P Canada. Thank you very much. Fahd Ben Kiran, the CEO of UM6P France. Huda Ghouzi, the CEO of OST, Deep Tech. Jalal Sharaf, the Chief AI Officer, that I always call the Chief Innovation Officer for a reason. Karim Ammour, the Elon Musk of Morocco. Kate Hatch came in from Germany, believing in the potential of Africa. Marwan Burada Suni, one of the smartest guys based in Silicon Valley and believing in the Deep Tech Summit. Nawaz Shraibi, the CEO of Masir. Salma Talha Jibril, coming from Qatar. Steve Siansky, one of the legends of Silicon Valley. And Vianney Mahomed, who's a deep tech investor as well. So I think we need to move forward. So I would like to thank you all. I would like to thank you all for your presence, for your ideas, and also for your belief in the Deep Tech Summits. Thank you very much.